Hey guys, so what we're going to do today is we're going to look at dividing monomials, which is the complete opposite of multiplying them. So if you know the rules for multiplying, you're going to know the rules for dividing. So let's look at our worksheet where it says to divide x to the fifth over x to the third, or x to the fifth divided by x to the third. Now, the best way to do this or to explain how these rules work is by using our expanded exponents. So I'm going to take x to the fifth, which just means x times x times x times x times x, over x to the third, which just means x times x times x. Now, back when you were little and you had 3 divided by 3, that became 1. Now, what if I had x divided by x? X divided by x is also 1. So anytime you have a common factor in a numerator and a denominator, you can cancel them out because they are a factor of 1. And that doesn't affect the problem, just makes it look smaller, but keeps it equal. So once I cancel out those factors, I'm left with just 2 x's here. So x times x is really just x squared. Because I remember multiplying, you have x to the first times x to the fourth. First, you keep your base, add your exponents. So x times x is x squared. Now, the clue here is, how do we get from x to the fifth divided by x to the third to get to x to the second? So what you have to recognize is that when dividing, you're going to keep your base, and this time you're going to subtract your exponents. So that's our rule for dividing. So pause the video and make sure you get that down. So what is the rule for division? Keep the base, which is the big number, and subtract exponents. Sorry. All right. Pause the video and write that down. So we're going to try a couple more now. So using that law, and again, they have to be the same variable to be the same base. So we're going to keep the base of x and subtract our exponents and get 6. On number 2, go down here. A to the 10th divided by a to the 5th. We're going to keep our base, which is a, subtract the exponents. 10 minus 5 is 5. And on number 3, we have c to the 5th divided by c to the 4th. We're going to keep our base and subtract our exponents and get c to the first. Just remember, I'm going to remind you, we have 5 c's on top over 4 c's on bottom. Cancel them all out, and you're left with 1c, which is c to the first. So that's where this law all works out. All right, what about number 4? We have x to the 7th divided by x to the 7th. Keep your base, subtract your exponent. You get 7 minus 7 is 0. And number 5, you have x to the 10th divided by x to the 3rd. Keep your base, subtract your exponents. 10 minus 3 is 7. And then in number 6, you have 10 to the 8th divided by 10 to the 7th. You're going to keep your base, which is 10. You're not dividing them. A lot of people, when you write them like this, even though they mean the same thing, they want to divide the 10s. You're not. Remember, this means there's 8 tens straight, and you're crossing off 7 of them. So you're going to be left with 10 to the first, which 8 minus 7 is 1. You're not left with 1. You're left with that whole factor of 10. So it's really important that you recognize and memorize these rules, okay? All right, so pause the video, make sure you get this down. So what we're going to do is, using laws of exponents, we're going to keep the base and subtract the exponents. We're going to just kind of develop a really fun law right now. So we have 3 divided by 3. Now, our exponent in here is 1 because it's invisible. So we're going to keep the base and subtract the exponent, and we get 1 minus 1 is 0. How about 1,000 divided by 1,000? We're going to keep the base, subtract the exponent, and we get 0. What about negative 2 divided by negative 2? We're going to keep the base, subtract those exponents of 1, get 0. And x divided by x, we're going to keep the base, subtract the exponents, which are invisible. We're going to get x to the 0. Now here we're going to keep the base. Now that 4 has a little 1. So we have 4 to the first divided by 4 to the first. We have 4 to the 0. x to the second divided by x to the second, keep the base, subtract your exponents, you get x to the 0. And y to the third divided by y to the third, we get y to the 0. Now you're like, why would I write it like that? Because I told you to. Actually, -2 divided by -2. Yeah, I should write it like that, -2 in the parentheses. So that's using laws of exponents. But many of you know that 3 divided by 3 in your calculator is 1. 1,000 divided by 1,000 in your calculator is 1. Now, why is it that we're getting 1,000 to the 0 power? Well, that's because we were using our laws of exponents. So what we're going to try to explain to you today is that these are equivalent expressions, meaning 1,000 to the 0 power really could be also written as 1. So this is another really important detail for exponents. So I want you to pause the video and make sure you get all these notes copied down. And what's the important part? Well, first of all, anything divided by itself is 1. But we also stated, gotta erase that, sorry. Anything to the 0 power is also 1. Because when we divided these by itself, we got 3 to the 0. But when we divide it using numbers, we got 1. 1,000 divided by 1,000, we said was 1. But we also said it was 1,000 to the 0 power. So there's really something special about this property. It's called anything to the 0 power is 1. So make sure you memorize that, okay? And we're going to get to that in a minute. All right. So using our laws of exponents, we're going to now divide monomials by monomials. So you're going to divide the coefficients, keep your base, and subtract your exponents. So let's look at these examples. So let's try number 1. So in number 1, we now have coefficients. So we're going to divide our coefficients, keep our variables, subtract our exponents. So in number 1, we have -30 divided by 2. And you're actually going to plug that in your calculator and get -15. Keep your base, which is x, subtract your exponents, and you get 2. Let's try number 2. We're going to divide our coefficients, -21 divided by 3, 7. Now we're going to divide a to the 5th divided by a to the 4th. We're going to keep our a, but we're going to subtract our exponent. So what's 5 minus 4? You get 1. And now we're going to do our b's. Keep your b, but subtract your exponents. B to the 4th divided by b. But remember, there's an invisible 1. So 4 minus 1 is 3. So that's your final answer there. Number 3, you're going to divide your coefficients. 12 divided by 4 is 3. Keep your y. Subtract your exponent. 2 minus 2 is 0. And then we have z to the 2nd divided by z. So you're going to keep your z, subtract your exponents, and get 1. Now this y to the 0, we said anything to the 0 power is 1. So that actually cancels out. So our final answer here is going to be 3z to the 1st, which is in simplest form. So if you kept it as y to the 0, they probably won't have an answer choice with that. Just beware. All right, number 4, keep your base, divide your coefficients. 12 divided by -6 is -2. X to the 2nd divided by x to the 1st. Remember, put your 1. Keep your base, subtract your exponent. The y has nothing to subtract with, so you just keep it there like that. All right, number 5, we have 8 divided by 16. If you put that in your calculator, you get 0.5, which is really a half. Now you have a to the 3rd divided by a to the 1st. Keep your base, which is a, subtract your exponents. 3 minus 1 is 2. And b to the 5th divided by b. Keep your base, subtract your exponent, and get 4. So in its simplest form, it's going to be 1/2 a to the 2nd, b to the 4th. Okay? And last but not least, we have 15 divided by 20. If you put that in your calculator, you're going to get 0.75, which really is 3/4. So it's important to know your fractions. So you get 3/4. And now for this one, m to the 4th divided by m to the 3rd, you're going to keep your base, which is m, subtract your exponents. 4 minus 3 is 1. And then n to the first divided by n to the first. Now, you'll notice it's n divided by n. Anything but divided by itself is 1. So that fact you don't really have to write, but let's just do it in exponents. Keep your base, subtract your exponent. You get n to the 0, which that whole thing can simplify to 3/4. M to the first, which we're not going to write the first because that's an ugly exponent. It's fine. 1's fine. But n to the 0, remember, gets canceled out because anything divided by itself is 1. We don't write that factor of 1. That n to the 0 or 1 kind of gets disappeared. So that's going to be dividing exponents. What you're going to do now is make sure you pause the video, copy this down. And how well do you think you got it? Did you get it? Almost get it? Kind of get it? Nope. Not sure. But I want you guys to, if you have any questions, message me. But if not, then go back to the Google Classroom, complete the Castle Learning assignment on dividing monomials. And that will be it for the next 2 days. And then we have one more lesson to learn and then a review quiz. And we're done for the year, guys. God, man, this has been crazy. But I miss seeing you all. And I'm proud of how well you guys have been keeping up on this work. Like I said, message me if you have any questions.